In this video, we're going to explore experimental design. Now, first thing we want to do is know, how do we design a study? First, we want to know what are our variables that we want to measure and what's our population. Next, we want to know how are we actually going to collect that data. And if we're going to use a sample, we want to make sure it represents our population. Then we want to collect the data, and then we're going to use descriptive statistics to describe that data. And using the descriptive statistics, we're going to try to make decisions about the population using inferential statistics. And finally, we always want to make sure to identify any possible errors that could have occurred within our study. Now we have four primary methods for collecting data: observations, experiments, simulations, and surveys. Within observations, a researcher observes and measures characteristics of interest. For example, maybe someone goes in and they want to see, how do toddlers share new toys? So they're just going to go into a classroom, sit and watch and see what happens as new toys are brought to toddlers. In an experiment though, they actually create two groups where one will receive some form of a treatment and see how the responses occur. For example, maybe one group will get aspirin and another group gets nothing, and they want to see after a year who has fewer heart attacks. With a simulation, we can use mathematical, physical, or even computer models to reproduce conditions. And oftentimes these are done with computer simulations because they're too dangerous to do with actual test subjects. For example, the automobile industry uses crash test dummies to simulate what would happen when cars are hit in certain directions in a crash. And using that, they continue to work to make their cars safer. And the last method, in a survey, we go around and we're going to collect information about one or more characteristics of the population, often through mail, email, or even a phone survey. For instance, maybe there's a survey going around to determine why students took statistics. So let's look at a couple problems here and see if we can determine the method. So if we want to study the effect of changing flight patterns on the number of airplane accidents, well, knowing that you could increase the number of accidents or decrease, and we're not sure, that's too dangerous a chance to take, so we do that through simulation and see what would occur. Maybe a study on seeing, does eating oatmeal lower blood pressure? Because we're talking about doing something specific, in this case eating oatmeal, and what's its influence, we could create an experiment where one group eats oatmeal and another group does not eat oatmeal and see how does that influence their blood pressure. If we want to observe how fourth grade students solve a puzzle, we would just sit back and do an observational study and watch. We wouldn't actually do anything to the students. We'd let them just work and see how they do it, because we don't want to influence anything. We just want to characterize what is occurring. And the last one, a study of U.S. residents' approval rating for the president. This would be considered a survey because you're going around and asking them a question. Do you approve the way the president is handling his job? Now, as we start talking about experimental design, there's several elements. The first being control. And what control means is that we want to make sure that only one variable is being measured. If we start to measure more than one variable, that's considered confounding. And if we're confounding, we can't tell the difference between which of the different variables is actually influencing the change that we may be seeing. For example, if I was doing extra study work with students and they're also going home and studying more time afterwards, I wouldn't know, is it my study group? Is it their additional studying? Maybe they're sleeping more. There's so many factors that I have to take into consideration that could be confounding. Another instance that can happen with control is this idea called the placebo effect. And the placebo is something we give, especially in medical treatments, where it's actually not any form of treatment. But the placebo effect means that the subject is going to react favorably to that placebo even though they didn't receive a treatment, but they think they did. One way we deal with this is we use blinding techniques, where the subjects don't know whether they got the placebo or the real drug, and we see what influence then the drug has on the participants. Also, in some cases, they do double blinding to be more rigorous, so even the researcher does not know who received what treatment or placebo until they're analyzing the data so that they cannot do anything to influence what's occurring in the study. Another element is randomization, because we want to make sure we're randomly assigning our groups. One way you can do that is just take our sample and completely randomize. So we have our sample and we randomly choose who goes to what group. No ways that we figure that out, just done randomly. Whereas if we do a block design is going to try to characterize people in the sample into similar groups, so then from those we can randomly select. And that the idea is that you can get a better representation in each of those treatment and control groups. One way we do this is with age. Maybe we do 10 to 20, 20 to 30, 30 to 40, and then within each of those age groups, we randomly assign who's in the treatment and who's in the control. And this last method, the matched pairs design, is probably one of the least used because you need two subjects to be virtually identical in all possible ways, and that's done mainly with twins. And one group will get a treatment, the other one will not receive a treatment. So you can see how that'd be very difficult to have two people that are virtually identical, one receiving a treatment and one not. So let's look at this study and see what's wrong with their design. We have heavy smokers, and so they want to do a study to see how they can help them quit smoking. So they first split them into blocks. So they use that randomized block design. However, when they split into blocks, they give one entire block, the female group, the new gum, and the male group only receives a placebo. And they see that after 2 months, the females have a significant number of quit smoking. So what's the problem here? Well, the problem is that when we do a randomized block design, it's not that one block gets the entire treatment, it's that we split into blocks and each block is randomly assigned parts. So that's where their issue is. We don't know whether females have any different influence from the gum than men would, so that's important to pay attention to. So we'd fix this by saying we'd randomly assign females into each of the groups and we'd randomly assign males into each of the groups. Now our last part here is we can have different sampling techniques. For instance, we can have a simple random sample where from the population every person has the same chance of being pulled. That's the important thing. Everyone has the same chance. Whereas when we stratify, what we're doing is we're going to take our population and split it into subgroups. And from each subgroup, we randomly select people to be part of our study. For instance, this could be done by income level, where you have low, middle, and high incomes, and you're randomly going to select from each of those different groups to be part of your sample. In a cluster sample, we do this when we have large populations and we split the entire population into groups. And what we do then is we randomly select a group or several groups from the population that we've done, and we do the sample or we do the study on everyone within that group. So an easy way to look at this, say there's all of our introduction to statistics classes. If we randomly select, say, 4 or 3 classes from all the intro classes, and we then do a study on every single person within those 3 or 4 classes, that would be a cluster. The last one is systematic. Systematic, we start with a random number, and then every member after that at a certain interval will be done. So this is often done when you look at police stop checks. They'll take a random person at first, and then they have to stop every 5th or every 7th car and check out everything from license, registration, ask certain questions depending on what they're trying to do, so that they can say that they are randomly selecting people to be as part of their checks. Now, one method we do want to avoid is called the convenient sampling. And this is where you choose whoever you can to be part of your study. And the problem is you're no longer representing the population at that point, because you don't know whether they're going to make up part of our population, and that's going to be biased in your study, and it's not going to be accurate. With these 4 methods, we're randomly selecting in some form, and so we're more likely to have a representation of the population. So this is what we want to try to do whenever possible.